Okay, so let's begin with our new chapter of electrostatics. So this chapter is actually talk about the electrics. Electrics. So let's begin with the first subtopic, which is Coulomb's law. Coulomb's law. So what is actually Coulomb's law states? So Coulomb's law actually states that the electrostatic force is directly proportional to the product of the two charges, but inversely proportional inversely proportional to the square of distance between two charges. Okay, so or we can say that distance between to the square of distance between them. So this we can use in the terms of the simplified sentence, which is between them. Alright, so this is the definition for the Coulomb's law. So in terms of formula, so what we have is the electrostatic force. So electrostatic force is actually directly proportional to the product of the two charges. So the charges we denote the charges as Q, which is Q1, Q2, and inversely proportional to the square of distance between them. So which is R square. So this Q1, Q2, we are able to write it in the form of a capital letter, or we can write it in the form of small letter. So okay, so let me just erase this one. Okay, so in this relation, what we can have for the equation is actually F is equal to at the constant. So this is Q1, Q2 over R squared. So this R basically is equal to 1 over 4 pi epsilon. So this epsilon is actually meant by uh, permittivity of free space. Permittivity. So this is permittivity of free space. Okay, so this is 4 pi, and what we can write for this formula is basically is Q1 Q2 divided by 4 pi epsilon R square. So this permittivity of free space is the space that occupied by the two charges. Okay, so this K so depends on us which formula is more favorable to us to write. So for me, it's actually this is my preference, which is the K can be simplified in from the 4 pi epsilon. Okay, so this K basically has a value since all the variables are the constant, so the value given here is actually 9.0 times 10 to the power of 9. So what? Okay, so this will be its SI units. So this is the SI units. Okay, so this is um, the definition for Coulomb's law. Alright, so we have done for this parts. So let's just move on to the other parts. Okay, so we know that the electrostatic force, which is also one of the type of the force, electrostatic force. So electrostatic force is actually one of the type of the force. So force, we know that consists of magnitude and direction. So, okay. So force is actually consists of magnitude and direction. So the magnitude of the electrostatic force can be calculated using this formula. So kq1 q2 over r square. As for the direction, direction is depends on the type of charge. Type of charge. So from here, depends on the type of charge. It means that, okay, let me just draw it here. So it means that if both charges, which is both of them is positive, so both positive charges eventually will repel each other. So this I can conclude that the direction of this Q1, the force of the direction of the electrostatic force of this Q1 is actually to the left. And as for the Q2, the electrostatic force is actually direction towards the right. So this is how we find the definition, the direction for the electrostatic force. So as for another example, so let me just, okay. As for another example, so let's say I have a positive charge and I have another negative charge. So basically positive and negative will attract each other. So since the both charges attract each other, so I can conclude that my positive charge is actually towards the right. So as for the negative charge, the direction of the force is actually towards the left. So this is how we determine the direction. Okay, so as for the negative, this is also similar to the both positive charge. So this one shall be to the left and this one shall be to the right. Alright, so this is how we find the magnitude and direction of the different type of charges. Okay, so we have done for the definition of Coulomb's law, which defines the definition of electrostatic force. So let's look out for the differences. So as we talk about the electrostatic force, what we observe is actually the formula is actually quite similar to the formula of gravitational force, but since they have the similarities, but their property is actually different. Okay, so let's just discuss about both forces. So let's say I have my electrostatic force, and I have my gravitational force. Gravitational force. So the electrostatic force, which is F, is actually equals to the K Q1 Q2 over R square. As for the gravitational force, F is equal to negative G M1 M2 over R square. So as you can see that um, for the electrostatic force, there is actually no negative sign in here. So as we talk from the gravitation chapter, we said that the negative sign for the gravitational force is actually meant by both object, or we can say both masses, is actually attractive. So this is I can conclude that the gravitational force is actually consists of is only the attractive force. So okay, so as a conclusion, the gravitational force is actually a attractive force. Attractive force. As for the electrostatic force, so as we observe uh, from the interaction between different type of charges, or the same charges or the different type of charges, the interaction between the same charges or the interaction between different of charges. So I can see that the force is actually, for the similar charges, is actually repel. As for the different charges, the force is actually attractive. So I can conclude that so let me just erase this one. So I can conclude that my electrostatic force can be attractive and repulsive. So electrostatic force, the direction of electrostatic force is actually depends on the interaction between different type of charge. Okay, so this is the first differences, okay, between the electrostatic force and gravitational force. As for the second difference, so the second difference is the electrostatic force is inversely proportional. Okay, let me just draw a line. Okay. Inversely proportional to the square of distance between two charges. Between two charges. As for the gravitational force, is inversely proportional to the product of um, inversely proportional to the square of distance between two masses. So the difference is the one of them is concerned about the charges, and another one is concerned about masses. So that's the difference between the electrostatic force and gravitational force. Okay, so after discussing about the magnitude and direction of um, electrostatic force, so for the next step, what we need to do is actually know and understand how to calculate and determine the direction of electrostatic force. So for the first example, so let's say I have a positive charge. So this is also a positive charge and this is also a negative charge. So to remind that this positive doesn't mean by the proton and electron. So this is the different type of charges. So let's say my Q1 is actually equals to plus 35 um, mil coulomb. So as for the Q2 is actually equals to plus 47 mil coulomb. As for the Q3, so what will be the Q3? Negative 53 mil coulomb. So this the distance separated between Q1 and Q2. So let me draw for a moment. So this is the distance separation between Q2 and Q3. So this is 28 cm. So this is 75 cm. Okay, so my question is, find the resultant force acting on Q1. Okay, so since the electrostatic force concerns about the magnitude and direction, so both of them we must determine it in the form of more precise and very clear. Okay, so let's do it. So the resultant force acting on Q1. So this is the Q1 and this is the Q2 and Q3. So basically there are two charges interacting with Q1. So two charges interacting with Q1, it means that there is two forces acting in Q1. So let's find for the first forces, which is the forces between Q1 and Q2. So I denote this one as F12. So F12 is basically equals to K Q1 Q2 divided by R square. So my 9.0 times 10 to the power of 9. So Q1 basically is 35. So mu is times 10 to the power negative 6. So Q2, okay. So my Q2 basically is 47 times 10 to the power negative 6. Okay, so what will be the distance? So the distance is 28 times 10 to the power negative 2 square. So what I found for the F12, 9 times 10 to the power 9, 35 times 10 to the power negative 6, 47 times 10 to the power negative 6. So this is 28 times 10 to the power negative 2 square. So basically the force for F12 is 188.8. This is Newton. So okay, and my F12 is 18. Let me just write at other places. Okay, so let me denote this one at here. 188.8 Newton. So let me just erase this one. Okay, alright. So this is force between Q1 and Q2. So what about the force between Q1 and Q3? So what I have here is actually F13. So okay. So the force between Q1 and Q3 basically is KQ1 Q3 over R square. So my K is 9 times 10 to the power of 9. So my Q1 is 35 times 10 to the power negative 6. So my Q3 is basically 53 times 10 to the power negative 6. So to be reminded that the direction, the negative sign of this Q3 is actually not required for the magnitude of the force. So the negative sign of this Q3 can be neglected in the calculation of the electrostatic force. Okay, so my R is actually 28 plus 75. So 28 plus 75, what we get is actually 103 times 10 to the power of 2, negative 2, and this is square. So 9 times 10 to the power of 9, so 35 times 10 to the power negative 6, so 53 times 10 to the power negative 6, so divided by 103 times 10 to the power negative 2, and square. So what I get for the F13 is actually 15.74. So this is Newton. Okay, so alright, so just now I missed something, which is the direction of F12. So F12, the force exerted by Q1 between the interaction between Q1 and Q2. So since both of them is positive charge, so it means that both of them is actually repulsive. So I can conclude that my F12 is actually towards this direction. So this direction is actually towards the left. So this is the left. Okay, so this is F13. So between Q1 and Q3, so both charge are different. So it means that both charge is actually attractive. So attractive, it means that the Q1 is actually about to move towards towards the right side. So this is 1 3, and this is to the right. Okay, so let me just write it here. 15.74 Newton. So this is right. Okay, so we have done for F13, and let's find out what will be the resultant force. Okay, so the resultant force um force so now what we need to do is actually observe between these forces. So what we can see that the magnitude, the biggest magnitude between these forces is actually F12. So what we need to do is actually find the difference between the F12 and F13. So F12 minus F13. So 188.8 minus 15.74. So what we get for the 0.74, and what we get is 173.1 Newton. So okay, so this is the final answer, and this is only the magnitude. And what about direction? So as we can see that the force toward the left is actually bigger than the force toward the right. So actually the F12 is actually overrides the F13. So the resultant force is actually towards the direction of left, since the F12 is stronger than F13. Okay, so this is to the left. So this is how we find the magnitude and direction of the electrostatic force. So we have done for this one. Okay, so let's find out for another example. So let's say, okay, let me just erase this one. So let's say I about to find the resultant force exerted on Q2. So resultant force on Q2. So the resultant force of Q2. So basically the interaction for Q2, how should I inscribe this one? There are two charges, which is Q1 and Q3, interacting with Q2. So it means that there is also the two forces acting on Q2. So what we need to do is find out the resultant force. So the interaction between the Q1 and Q2 is actually F21. So F21 Q2 Q1 is R squared. So basically this forces is actually equals to this one, which is 188.8 Newton. So the difference is only in the form of in the terms of direction. So basically, just now we mentioned about the Q1 is actually towards the left, since both of them are repulsive. So now, the main point for us is actually Q2. So the Q2, the force 1, 2 is actually towards the right, to the right. So this is the F21. So let me just erase this one. Okay. Oops. Okay. So this is F21. F21, which is 188.8 Newton. Sorry. 188.8 Newton. Alright, so this is F21. So what about F23? So let me just erase this one. So for F23, so what we need to do is actually calculate the F23, which is Q2, Q3 divided by the distance between them. So 9 times 10 to the power of 9. So this is 47 times 10 to the power negative 6. And Q3 is 53, so negative sign is neglected. So this is negative 6. And the distance between them is actually 75 centimeter. So centimeter convert to meter. And this is the square. And what I have for this F23, 53 times 10 to the power negative 6, so 75 times 10 to the power negative 2. So this is the 39.9, and this one should be the right side, to the right, 39.9 Newton. So 39 point, sorry, I should write it in the form of 4 significant figures. So 39.86, and this is Newton. So basically, F23. So this is since both of them are different, so the force is actually attractive. So the force exerted by Q2 is actually to the right side. So okay, I have found the F23, which is 39.86 Newton. So this one is right. Okay, so let me just erase this one. And since both forces are positive, not positive, sorry, both forces are towards the right, so what we need to do for the resultant force is actually F21 plus F23. So this is 188.8 plus 39.86. So 188.8 plus 39.86. So what I get is actually 228.7, and this is Newton. So this direction is to the right. Alright, so this is how we find the electrostatic force. And so this is the forces which exist in one plane. So what about the electrostatic forces in the both horizontal plane and vertical plane? Okay, so let me just erase this one. Okay, so just now what we talk is only the horizontal in the form of horizontal plane. So what about the magnitude and direction for both horizontal and vertical plane? So let's say I have my charge here, and this is my positive charge, and this is also my positive charge, and this is the one that is negative charge. So the distance between here and this here to here basically is, oops, okay, so this one shall be the dotted line, and the distance between here is actually 50 cm. As for this one is 65 cm. So this considered to be my Q1. So my Q1 basically is plus 72 nano coulomb. So as for the Q2, so the Q2 is this one, is equals to the positive 45 nano coulomb. So as for the Q3, so my Q3 is negative 38 nano coulomb. So the question is, find the resultant force acting on Q2. Resultant force on Q2. Okay, so this, as I said, that this actually involved the two planes, which is horizontal planes and vertical planes. Alright, so let's find out the electrostatic force between the Q2 and Q1. So remember that the key point, the charges that we concern is Q2. Okay, so let's find out the electrostatic force for Q2 and Q1, which is F21. So this is K Q1 Q2 over R square. So this is 9 times 10 to the power of 9. So Q1 basically is 72 times 10. So nano is actually times 10 to the power negative 9. So Q2 is 45 times 10 to the power negative 9. So divided by the R square. So my R square basically is 50 times 10 to the power negative 2 square. Alright, so this 9 times 10 to the power of 9, 72 times 10 to the power negative 9, 45 times 10 to the power negative 9, so divided by 50 times 10 to the power negative 2, and square. So what I have for my F21 is 1.166 times 10 to the power negative 4, and this is Newton. Okay, so since both of them are positive, so it means that the force is actually repulsive. So the repulsive causes the Q2 to be moved downwards. So my F21 basically is 1.166 times 10 to the power negative 4 Newton. So this is downwards. So this is F21. Okay, so let's find out for the forces between Q2 and Q3. So Q2 and Q3 basically is F23. So K Q2 Q3 divided by R square. So this is 9 times 10 to the power of 9. So Q2 is 45 times 10 to the power negative 9. So my Q3 is 38 times 10 to the power negative 9. So divided by the R square. So my R square is actually 65 times 10 to the power negative 2 square. Okay, so 9 times 10 to the power of 9. So 45 times 10 to the power negative 9. So 38 times 10 to the power negative 9. So divided by 65 times 10 to the power negative 2 square. So basically the F23 is 3.643 times 10 to the power negative 5 Newton. So this is the F23. So this is the magnitude. So what about the direction? So since both the charges are different, so it means that the force is actually attractive. So the force attractive causes the Q2 to move to the right. Okay, so this will be my F23, which is 3.643 times 10 to the power negative 5 Newton. So this is to the right. Alright, so this is F23. So we find out the magnitude and direction of the both forces. So what we need to find is actually the resultant force. So this is, let me draw a diagram. So this considered to be my Q2. And the force acting on Q2 for two forces, which is F21, which is pointing downwards. As for the F23 is actually to the right, and this one shall be F23. So what we can observe, these two forces is actually creating a horizontal force and vertical force, and the resultant force that we can find basically is the forces between these two both two components. So this is the consider the vertical components, and this consider to be the horizontal component, and this one shall be our resultant force, which is F2. So I can conclude that my F2 basically is equal to the square root of F23 square plus F21 square. So what will be my F23? So 3.643 times 10 to the power negative 5, and this is square plus, so let me just drag it to the right, plus F21 1.166 times 10 to the power negative 4, and this is square. So basically my F2 1.166 times 10 to the power negative 4, 2. So basically my F2 is actually 1.222 times 10 to the power negative 4 Newton. So Is it correct? Okay, so there's something wrong here. So I wonder where is the mistakes which I have done. So let me check for a while. So this one shall be, yeah, so wait a second, I need to find it out. Okay, so this is 45 and this is, yeah, I think this shall be the answer. Okay, so this is the magnitude of the resultant force. So what about the direction? So the direction is actually here, the angle. So what will be my angle? So my angle basically is tangent. So tangent is actually equals to the opposite divided by the adjacent. So my opposite, which is this one is actually parallel to the F21. So my F21 divided by F23. So this shall be my direction. So my theta, so I I directly find out the angle of theta. So I didn't sub the magnitude of the both f21 and f23. So this is basically is 1.166. So 1 point. So 3.3 and 3.643 times 10 to the power negative 5. So what I get for the final answer basically is 72.6 degree. So I directly skip out the substitution parts. So the substitution part is actually necessary. So this is the direction. So this direction is actually the horizontal from the horizontal. So this is the angle. Alright, so this is how we find the electrostatic force in the form of two component, which is vertical component and horizontal component. Alright, so we have done for all the electrostatic force parts. Okay, so let's just move on to another subtopics. Okay, so wait a second. Alright, so let's move on to another new subtopic, which is the electric field. So electric field, what is actually meant by electric field? So electric field is actually a region where electric charge experiences electrostatic force. So electric field is basically a region where electric charges experience electrostatic force. So this is the electric field. Okay, so basically electric field is actually same as has the similar concept to the gravitational field, which is the electric field is represented in the form of electric field lines. So this is the property of the electric field. Alright, so since we talk about the electric field, so we need to talk about another most important part, which is electric field strength. Field strength. So we have the gravitational field and we have the gravitational field and we have the electric field. So we have the gravitational field strength and hence we also have the electric field strength. Same concept but different description. Okay, so what is actually the definition for electric field strength? So electric field strength is defined as, so at a certain point is the force per unit charge, per unit positive charge. So basically, for the formula, it's actually E equal to electrostatic force divided by the total charge. So what the statement means is, so let's say I have my positive charge. So this is the one of the point. So I denote this point as X. So the electric field strength, which is towards here, electric field strength is actually the force per unit positive charge which exerted by the point X. So how should I inscribe this? So this point is actually exert exert the force which produced by this positive charge. So these forces, so electric field strength is actually describing the force for 1 unit charge, 1 unit positive charge. So this so I repeat again. So let's say I have my positive charge and this is my point X. So this point X is actually exerting the force which acting on the positive charge. So this positive charge may be interacting with another charge which is negative charge. So this positive charge, so this region is actually consists of electrostatic force. So this point X is one of the region that exert electrostatic force. So the electric field strength is actually describing um, the force for 1 unit positive charge. So this is what the electric field strength describing. Okay, so this is the definition for electric field strength. Okay, let me erase this one and this one as well. Alright, so let's move on to okay, so let me give me a moment. So as for the positive charge, so let's say the forces of the positive charge is actually towards here. So the direction of the electric field strength is said to be the similar direction with the electrostatic force. and this is for the positive charge. And as for the negative charge, so let's say these two charges are actually interacting. So this forces for the positive charge, the forces is actually towards the right. So as for the negative charge, the forces is actually towards the left. So the electric field strength, um, which acting towards the negative charge, is actually opposed to the direction of force of the negative charge, which is towards the right. Since the electric field strength is always same as the direction of electrostatic force from the positive charge. Okay, so this is the definition. This is how we determine the electric field strength, which exerted on the both positive charge and negative charge. So let me just write down the statement here. So E is the same direction of with the positive charge with the force of positive charge. So as for the negative charge, E, so this arrow is actually means the direction. E is opposite direction with the force of negative charge. So we can see that the electric field lines is actually always towards the electrostatic force which exerted on positive charge and opposing the electrostatic force which exerted towards the negative charge. Alright, so we have done for this part. Okay, so let's move on to another part. So let me erase this one. So since the electric field strength or the electric field is actually represented in the form of electric field lines, so what we need to discuss from the next coming subtopic is actually the electric field lines by a point charge. So let's begin with the charge of positive. So positive charge, so let's say this is the positive charge. So the direction of the positive charge can be this way, can be this way. So let's say this will be my F1, and as for another force can be toward this way and this way, this way, and this way, this way, this way, and finally this way. So the positive charge is actually can move towards this direction. This so 1, 2, 3, 4, 5, 6, 7, 8. So this 8 direction could possibly be the movement of the positive charge. So since the direction of the force is towards this direction, so this same goes to the electric field lines. So the electric field lines is actually also represented in these 8 lines. So so I can conclude that finally the electric field lines by a positive charge is actually pointing outwards in this eight direction. Okay, so this shall be the electric field lines of the positive charge, and we have the negative charge. So okay, so since the so let's draw these lines as well. So force, as for the positive, force is same direction, as electric field. So force is, so I should write it in the form of electrostatic force to be specifically electrostatics force. Electrostatic force is opposite direction to the electric field. So, so this concept is actually similar as the positive charge. So the negative charge could be this eight lines could be the all the direction of the negative charge which will move forwards. So this I repeat again. So these eight lines could be the possible directions of the negative charge which will moving forwards. So since the electrostatic force, since the electric field lines is always opposing the electrostatic force of the negative charge, so hence I can conclude that my electric field lines for the negative charge is actually pointing inwards. So this is pointing inwards, and this is inwards, 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 and finally inwards. So this is how we determine the electric field lines by both positive charge and negative charge. Okay, so this is in the form of individual. So what about if two charges is actually interacting? Okay, so let me just erase this one. Okay, this one. So what if both different charges are interacting? So what we can see here, so the electric field lines is actually pointing, for the positive charge is actually pointing from positive to negative. So this one shall be pointing towards negative. So the electric field lines is actually combining. So this one is pointing outwards, and this one shall be pointing inwards. So this one is inwards. So if both charges are interacting, so the electric field lines, which is in the region of the electric field, so the both charges, the electric field acting on the both charges is actually in this form. So same concept. The positive charge is the electric field lines for positive charge is pointing outwards. As for the negative charge, the electric field lines is actually pointing inwards. So this is for the different charge. As for the similar charge, which is positive, so we know that the electric field lines for positive charge is actually pointing outwards. So this is positive, and this is positive, and this is outwards, sorry, and this is outwards, outwards, and outwards. As for as since both both of them are repulsive, so the electric field lines will not interacting to each other. So the electric field line is actually representing in this form. So this is pointing outward as well, pointing outwards, and finally pointing outwards. So we can see that, we can observe that both electric field lines are not interacting. So hence this is the direction of the electric field lines in the form of both similar charge and different charges. Okay, so we have done for the direction of electric field lines. So what we going to discuss for next is actually the magnitude of the electric field strength. So this is the derivation of the formula. Derivation of E. So as I mentioned just now, this is the positive, and this is the one of the point which exerted by the force. So which exerting force, sorry. So what we need to find is actually the force per unit charge, which is E. So the force per unit charge acting on this X. So let's say I have my charge Q in this point. Okay, so basically my my forces is actually equals to K, and this considered to be my Q, capital letter Q, and this point um consists of small letter q, and this is the distance between them. Okay, so this is small q, and in this case we does not consider about the direction, and what we need to do is actually find out the force per unit charge acting on x. So the E is actually F over Q, so KQ Q over R squared Q. So this can be cancelled, and finally the electric field strength acting on this point X is actually equals to KQ over R squared. So this is the magnitude for the electric field strength, and hence we have found the magnitude and direction of electric field strength. Alright, so we have done for the discussion for electric field strength. So let's just go through some examples. Okay. So let's take for an example. So let's say I have my negative charge and positive charge. So this this considered to be my Q1. So my Q1 is actually negative 12 mu coulomb, and this should be my Q2, and this is the positive 18 mu coulomb. So this point is our main concern here, which is the electric field exerted in this point. So this one is the distance, and this is the dotted line, and from here the distance between, so let me consider this one as x. So this one is the 80 cm, and this one shall be 60 cm. Alright, so the question is, find the electric field strength, find E exerted at x. So the question is actually asking about the resultant electric field, which is the force per unit charge acting at this point between when two charges are interacting. Alright, so what we need to do at first, we need to determine the direction of the electric field strength. So we can see that this is actually the negative. So the direction of the electric field is actually pointing towards, or we can say inwards, to the negative charges. So this one shall be my E1. As for the positive charge, so the electric field acting on the positive charge is actually similar to the direction of the forces. So the electric field strength is actually pointing upwards. So this one shall be E2. Okay, so what we need to find is actually find the E1. So my E1 is actually KQ1 over R square. So this is 9 times 10 to the power of 9. So my Q1 basically is 12 times 10 to the power negative 6. So to be reminded that the negative is actually not required in the magnitude, which is also similar to the electrostatic force. So this shall be our R square. So R square is 60 times 10 to the power negative 2 square. Okay, so 9 times 10 to the power of 9, 12 times 10 to the power of negative 6. So over the 60 times 10 to the power negative 2, and this shall be square. Okay, so what we get is actually 3.00 times 10 to the power 5, and this is Newton per coulomb, which is force per unit charge. And this one is actually pointing upwards. So this is the upwards. As for the E2, E2 is actually KQ2 over R square. So 9 times 10 to the power of 9. And the Q is actually 18 times 10 to the power negative 6. So the R square is 80 times 10 to the power negative 2 square. So what will be our answer? 9 times 10 to the power of 9, 18 times 10 to the power negative 6, divided by 80 times 10 to the power negative 2 square. And the final answer I get is 2.531 times 10 to the power of 5. So this is Newton per coulomb. Okay, so we have done for both E1 and E2. So what we need to do is find out the resultant force. Okay, so based on this diagram, I can say that, so this is my point X. So this shall be my E2. And this shall be my E1. So as we can see that both E1 and E2 are forming a horizontal component and a vertical component. So horizontal component and vertical component basically constructing a resultant electric field. So this is the resultant electric field. So the resultant electric field basically is equals to E1 square plus E2 square. Okay, so substituting all the value, so I directly skip that substitution. So that substitution is actually necessary. So 0.531 times 10 to the power 5, and this is square. And the final answer basically is 3.92 times 10 to the power of 5. So this is Newton per coulomb. So this is the resultant force. And what about the direction? So tangent theta is equals to E1 divided by E2. So E1 divided by E2, so I directly skip to the part of final theta, which is theta. 3 times 10 to the power of 5 divided by 2.531 times 10 to the power of 5. So what I get for the final degree is actually 49.9 degree, and this one is from horizontal. Alright, so that's it for the direction of the electric field. So what we have done is finding out the magnitude and direction of the electric field strength. So that's it for the parts of electric field strength. So I think we stop here and we will continue the next coming parts in the next video. So I'll see you next time. Thank you. Bye.